Okay, box-shaped vessel. Again, we're looking at the second method. Forward end compartment is bilged, no watertight flat. So when we look at the sketch here, 170 by 22, 9.2 draft. I think a couple of things I want to look at here. One is the LCF of the vessel. Because we've lost this waterline, the LCF is simply half the remaining distance. So the LCF will be 74.5. Okay, 74.5. And we need to calculate our trim lever. The trim lever is from the centre of flotation, the new centre of flotation obviously, to the centre of the bilge compartment. So from here to here is 74.5 plus 10.5 will give us our lever of 85. So two important things there. What's the LCF and what's the lever? Now let's look at the problem. Obviously work out your sinkage first. 1.297 gives a new draft of 10.497. Weight of the buoyancy lost, so it's just the volume times density. The trimming moment will be the weight of the buoyancy lost multiplied by the tank centroid from F1. The distance, and as we looked at the sketch, it was 85, so that gave us our trim moments. MCTC, usual formula, displacement and length doesn't change. kg doesn't change, so we need to look at the KML. And because this is symmetrical, the remaining part of the vessel, our KB will simply be the draft divided by 2. And importantly as well, the BML, the BL cube, the L, will be 170 minus 21. So that's 149. So that's, you'll notice that I've used that in the formula. And obviously the volume doesn't change because the displacement doesn't change. So that gives us our GML. Put that in the formula that we've got here, put the figures in and get the MCTC. That gives us our trim. Apportion the trim after and forward using the formula change of trim times LCF over length. That gives us the after amount. Subtract it from the total to get the forward amount, and then apply those values as you've seen there. And we get a very slight difference from the previous method, very slight, and it's only because of rounding with the figures.